So you want to change the grammar for the try statement, where if you have an except without the exception specification, a bare except or except colon, that needs to be last. I remember now. So in order to do that, we removed this if from the code gen, which is 92535 somewhere here, where the code gets what is n? N is the number of try handlers, and it generates code for every except. And there was an if where there's except handler, not except handler type, so that means the exception type was not set and the handler wasn't the last one, then this would raise a compile time error. And it would be nice if we want the grammar to be part of the docs, to put this in the grammar itself. Hopefully it'll make things faster as well. Who knows? That's, I guess, something to check when we want to get this merged. Anyway, so where is the grammar? We have an except block, and this, what we did last time, adds except block with exception type, which is what was here before, but without the final one, or a bare except block, right? And then invalid exception statement was also part of this except block. So far we've only split this except block into except block with X type and bare except block. Does that make sense?
It is, yes. I mean, it does.
All right. Let's see where that gets us. I think we didn't run the tests on this, did we? So let me keep
I think we did. I thought we did.
Let me keep that running just to see what fails. But what we want to do is look where this except block is referenced, and that would be in the try. I don't think it's used anywhere else, so there's invalid try statement as well. It says cannot have both except and except star on the same try. Cannot have both except and except star on the same try for something a bit different. Yeah, the error handling will be probably not be easy here, but let's change that when we get to it. Alright, so what does this do? There's try, colon, block, and then except block plus. And the tricky thing here that I don't know how to do yet is this type, ASDL except handler sequence. Which means there's more than one of these except block, and I don't know how this plus is then handled in the C code. We have else block named L, finally block named F, and this does pi_ast try, with B being the body of the try block, EX being all the excepts, EL being the else block, and F being the finally. Right? If you have a try without the excepts, then the exceptions and the else will be null. And I guess these are optional, so if they're not there, that'll be null as well. And then the except star version has a different function to call, which is pi_ast try star. So what I want to do now is I guess look up this pi_ast try function and see where that's oh, this is also generated automatically. ASDLC, it's generated automatically but from a different file. Right, so this gets ASDL accept handler sequence handlers, and we should preserve that. Now the issue we'll have is if I so let's first look at the grammar. So this will probably have two cases here. We can either have one or more accept blocks with the exception type, and then no bare except block, or we can have 0 or more except block with exception type, and then the bare except block. Then the bare except block is required. Okay, so I guess what I'll do here is put this except block plus into its own rule, right? So I'll call it except blocks.
Oh, interesting.
And say that this needs this type, and that should be except block plus, and this should have the same behavior as before. And meanwhile,
Okay.
tests ran, and there's a single test that fails because of the removal of the default except must be last. That's nice. Nobody relies on this really. So, okay, so this should do the same thing as before. I'll check with running make regen pegen and make, and then probably run test exceptions, this one. Okay, so this says there's an assignment from incompatible pointer type somewhere in generated code. Good. Hey, that's so let's see where that came from. So inside the generated code somewhere, so this is the except blocks rule, so this is the C code for the rule that I've just added. it will get this loop 137 rule, which will be something called an ASDL sequence. I guess that's a sequence of
ASDL? Okay.
what is that? Well, it's a sequence of something. Where was that? Oh, okay, and we're trying to get the type ASDL accept handler sequence. I wonder if those are actually different types. Because when I just did accept block plus here, that did have the type ASDL accept handler sequence. So can I just do this? Apparently. Yeah, that works. What does that do for the parser? Okay, so that retyped the loop 137 rule and cast it to the new type, which worked. So apparently the elements of the ASDL accept handler sequence are basically subtypes of the whatever the type name was before. That's nice. Okay. And now what I need to do is somehow break this up into two cases, because we can either have one or more accept block with exception type, or we can have 0 or more accept block with exception type followed by bare accept block. Right?
Yes.
So this one should be fine. And in this one, we need some way to append this, which, well, I guess that'll be accept handler type. I just do this. That's what accept handler type, and I need to append this to the sequence, and I wonder how you do that. Let's look in the parser. So apparently this call a function called loop 137 rule. Adds children, and oh dear, it manually calls C code to reallocate an array. And I guess that's the reason why this is not done in the grammar. Alright, this has a hidden or a local children capacity it doubles that children capacity every time. And appends reallocates whenever it grows. And I guess I would need to write that in the action here.
When there are multiple clauses, it calls the manual C code.
Yeah, so this is generated code. So this
It's
137 rule is the function that parses the loop inside the except block. So that's
okay.
Except block or except blocks. Cool. Except block. Wait, am I in the right function? Let's accept blocks rule. Calls. Oh, this is for the older version of the Python grammar. So this is when accept blocks was just accept block plus, and that calls the loop function inside. That might also make things less performant since we're adding a rule where previously there was just a loop. So that might be a reason to reject this change. Anyway, okay, so what this does is it loops over the accept blocks, and it will somewhere call the accept block rule function, which will parse the accept block, and then add this accept block var to an array here. So there's this C pointer called children, and it gets reallocated every time it's too short, right? And when it's too short, it grows by a factor of 2. Then the new accept block is added to it, and then the children are added to this ASDL sequence set. What is this? Oh, ASDL generic sequence new. Okay. Okay, so this is this is just internals. We get an ASDL sequence out of this. And what are the functions for dealing with ASDL sequences? documentation for it because somebody cared. That is nice. Alright, so allocate memory for an ASDL generic sequence of the specified length. I should really read this documentation before looking at the code, right?
Wow. It's deep. Yeah.
Right, source code to AST. Each rule creates an AST node as it goes along. So we have a lot of ASDL sequence structures, and there are some functions for that. You can make a new one, you can get items out of it, you can set items in it. But you cannot append an item to this, apparently.
It's so weird that we'd be using Markdown for this. Anyway.
Yeah, this is just text that doesn't get rendered anywhere.
Oh, I see. Okay.
Okay, get set. Yeah, looks like we can't grow the sequence. Also, how do you deallocate one? Oh, you probably... That's probably covered here somewhere, right? Memory management. Okay, the compiler is using an arena. Okay, so the way the compiler works is it just creates objects in memory in some area of the memory called an arena, and when the compiler is done, all of that memory is freed at once. So all of the objects, or all of the, well, not Python objects, but all of the ASDL sequences and everything like that gets destroyed at once. Okay, well, I'm less and less convinced that I'll be able to make this change, especially without sacrificing performance. But I guess I could always try. Do you think that would be worth it? Or is this already over your head?
Oh, it's yeah. This would be over my head. I don't know that I'd be able to. I mean, yeah. I mean, if you want to do it, fine. I'll support you. I suppose, but I won't be very much. Yeah. I mean, there are probably other people who could stand to gain more from the experience.
Yeah, and I see why the grammar is done this way. It's for performance, of course. Like, what we could do here, since...
For compile time performance, you mean?
Yeah, compile time performance, which is pretty
Yeah.
important, I hear.
Of course, yeah.
So, if I run normal Python from my system, Right, I cannot repeat the bare except 2 times. So the bare except is a bit special. I wonder if we should make it special enough to put it in this try. Right, so there's this pyast try function which creates an AST try node. Are you familiar with the AST module?
Not very much, no. I mean, I haven't used it much, no.
So this is basically an object-oriented representation of a Python program, and it has objects for the try statement, which has body, except handlers, then it can have an else block and a final block. So I wonder if it would make it closer to reality if it had one more of these.
Or like the bare block?
Or like the bare except clause.
The bare except clause? Yeah.
which people want to deprecate that because it's a foot gun, right? It catches keyboard interrupt and all of those errors that you don't really want to catch. Yeah, so that's probably how I would do this. Add a bare except handler to the AST, so that except handlers would then be just the ones with the exception types. But I'm really not convinced that this change would be accepted, because I think we say somewhere that the AST is can change in every Python version in incompatible ways, but changing it just to make the grammar nicer will probably not fly.
Yeah.
It would probably also be bad for the performance. So let's not do this. What we will need to do in the grammar what we will do is add a comment.
Oh, good.
I guess that needs a new branch. Document default exam. Reset. Make a new branch. And somewhere can I put comments here?
Oh, that looks like a good place for a comment.
Should we comment all of these?
I mean, it seems like it seems like it took us a while to figure this out. It would be a pity to just not let. I don't know. Like, where else would we put
Yeah, where else do we
this
put
as a
these?
right?
I mean, if I make another syntax poster, I want to put it on there as a
Well, yeah.
comment. Yeah, I
Well,
guess.
then,
Should we make this like more structured comment? Like,
yeah, I was gonna say it's too bad this is not restructured code because then we could create like a doc string or something.
well, a doc string is really only helpful if we find a way to show it in the docs.
Well,
And if we put a comment
right.
here, it'll
Oh, it will show up.
here as a comment.
Oh, that might not be bad. Okay, then
So
it'll be visible.
there's a comment called note, which is here. It's more for the implementers. So this ideally wouldn't show up in docs. Here's another note like that. Another note. Well, this note is actually important. This note should show up in the docs. This maybe. Two. More notes. Primary elements, lambda parameters. Here's a good note. And start of invalid rules. We do not want to put in the documentation. So I was thinking maybe we can come up with some kind of keyword or label like this note, saying here we're documenting something that is checked in a later step. Right? What would be a good word for
that? Like not a warning, maybe info or to do.
I want something more specific, like say this is something that gets checked in a later step.
Oh, I see. It's not a preamble. It's something that gets checked in a later step. So it's like almost like a prologue or afterthought.
Afterthought. Something that the grammar itself doesn't cover.
So it's like out of scope, or it's deferred
Deferred.
Deferred, yeah, maybe.
Yeah, well, better than note.
Yeah. Yeah, deferred or post-process or yeah. Deferred or deferral or yeah.
Or maybe call it by where it happens, like
Oh,
code gen.
yes, there you go. Yes.
On the other hand, maybe that's an implementation detail we don't want to document, like where that happens.
Oh, right, because this is not necessarily specific to CPython.
Well, this is. Well, this is specific to CPython. If you were making a different Python implementation, you could either change the grammar or you could implement it somewhere else.
I see.
I don't know. I have to look in the source for. Maybe there's a good synonym for omitted. Left out. Yeah.
Overlooked.
No.
No, not overlooked.
More like left for later.
Yeah.
Excluded.
Oh, that is kind of like deferred then.
Yeah, I guess deferred is fine. Well, not the perfect word, but let's go with it. Okay, let's do that then. And that gives us a good way to basically make a list of all of these and put that in the docs right now. So let's go through all of these and document them. So all of these should be in codegen.c under PyCompiler. So break, continue, and return cannot appear in an except star block. People wanted to change this so they can't appear in except as well, but that would break existing code. So let's put that in. Where would be a good place to put this? In break, continue and return, or an except star? Probably
except star, I would imagine, no?
Except star would be the one place to put it. So let me just note this here for now. But unlike in the error message, we probably need to be more explicit here, because if I have except star and inside that except star I do something crazy like define a function, I can probably return from that function, right? So I now have a return inside an except star, right? So the error is correct. That only appears when you have these directly in an except star.
All right. Okay.
But for the documentation, we'll need to be more explicit. Like what kinds of things can you have in here? Because it's not all compound statements, right? If I have if, well, that's a return as a function, of course. Right, so if it doesn't protect me, this break is for this while and not this while, so it's fine. But again, if I had an if here, that wouldn't work. So for documentation, we'll probably need to make this a lot more specific, and that'll be interesting. What's next? Non-default type parameter follows default type parameter. Right, so this is for type parameters. Right here, and that's type param sequence. What's the wording there? Not default type parameters. A non-default type parameter cannot follow a default type parameter. Right, next one. And that's actually something which could probably put in the grammar. Non-default type parameter follows a default. Right, so this is type different kinds of stuff. Yeah, we could probably put that in the grammar and make type parameters just as complicated as normal parameters, and we might not want to do that. Alright, then we have return outside function and return with value in async generator. So that would be in return. Right. Also, that. What's next? Break and continue must be properly in a loop. Default except must be last. We covered that. Lazy import is only allowed in module scope. One cannot lazy import star. I wonder if that could be changed in the grammar, or if things are too complicated, right? So this lazy cannot be used with that star, which means this entire thing would need to be duplicated, either in the text grammar or in the diagram. So another deferred note. and we have too many expressions in start unpacking assignment. That's a CPython implementation detail. But here, multiple start expressions in an assignment. That's interesting. So let's see where that would be. So an assignment. I guess this target. Cannot have multiple start expressions. Where is that? Assignment. Single target. Start targets here. Right, start targets. Several start target, and start target might have a star or not. Right. So deferred. So that would be star A comma star B equals something, right? Multiple star expressions in assignment. And I think that also goes for sub-expressions. Okay, we can have this. That's syntactically valid. It just doesn't unpack here. But then you cannot have this. It's not the.
I see.
But star targets. I might want to note this. Or the nested targets called, so star targets. So start target could be a target star with Adam. And that that goes to star Adam, which then goes to star targets tuple sequence, which then have multiple star targets. So I guess we should call this by its name if we use the name here. And this is now not really good for the end user of the documentation, like for the reader. This will need a lot of massaging. Keyword argument repeated. Okay, that's that is, so that's in a helper function that gets called from calls, and that's it. Just calls. Calls and classes. Okay. Okay, so where is that? So that would be function def. Def raw is the one without decorators, and that has params, which then goes to parameters, and that's the whole mess. So here we say keyword argument names might not be repeated, and the same thing is for classes. So that's the class definition, class def raw, and that has arguments, which goes to args. So there. And I guess we also have lambda params. And we also have type parameters. There's a bunch of these. Okay, next up, yield outside function. So yield cannot, yield and yield from may not be used outside the function. So that goes to here. Yield expr includes yield from, right? From the wording must not be used in an async function. Right. Start assignment target must be in a list or tuple. This doesn't happen in legitimate cases. Good. Multiple assignments to name in pattern. Alright, so that's for the pattern matching stuff. So match statement, the subject cases, case block, and these patterns. Yeah, this one's a bit complicated. I guess one of these closed patterns. Okay, patterns goes to pattern, which is as pattern or pattern. As pattern has as with an or pattern, and or pattern is a pipe separated list of closed patterns. So I guess in here multiple assignments to angles to the same name are not allowed. And then we have too many expressions in star packing sequence pattern. That's a limitation we don't need to document. And multiple starred expressions in sequence pattern. So we have unpacking as well. Where would that be? In the capture pattern, in the pattern capture target. No, that's the group pattern here. Sequence pattern, maybe sequence pattern and open sequence pattern. These stars. Does star pattern appear anywhere else? Just here, and maybe star pattern just here. This is getting more and more complicated, isn't it? Oh, name and wildcards make remaining patterns unreachable. So those must be lost. So this is a bit like the except case, where capture and wildcard make the remaining patterns unreachable, or would make any subsequent patterns unreachable. So they must be last. don't know how exactly that works if you nest them. I guess that will be something to...
How do you mean this?
Okay, so you match something and you do this. So this will basically assign x to y. So you cannot have more cases after that, right? Name capture y makes remaining patterns unreachable because this matches everything. Same the other way, if you match everything explicitly, you cannot have any cases after that. But if you have this, right, so this is valid, even though this makes that unreachable. Right, well, Python is just not smart enough here. I wonder what happens if you do like this. Right, so here x makes remaining patterns unreachable. Right? So it's not just individual case statements or case branches, it's also in these, whatever these are called, or patterns. Does that make sense?
Yeah, I think I get it.
First. Wait, can I do... What happens if I do this, for example? Right. Whew. Yeah, this is complicated to explain.
Do we want to call it a case, or I mean, is that the right word for it?
Yeah,
Or is it a statement?
no, there's no case. I don't know what to call this. A case block. No, block is only this part.
A statement? A clause?
Case clause. Okay. Or we do something else and we say Python reports unreachable patterns as syntax error if it can detect them. Ta-da! Or when it detects them. And we make the exact mechanics of the detection. Well, we leave those out. That sound good? As this looks rather hard to explain.
Yeah, that'll have to do for now, I think. I mean, it's better than it was an hour ago.
Well, sure. Okay, let's go with that now. We'll probably have to put that in the corresponding prose in the documentation before adding this comment. Maybe I'm just writing a to-do list for myself. Alright. Keyword attributes, keyword patterns.
No, I think you're absolutely right. We're writing a to-do list for the future.
Right, what do we have here? Keyword attributes, keyword patterns, length mismatch in class pattern. Oh, okay, this is interesting. This is not something we need to document, but if we look at the AST module, it should have documentation for the match pattern, and there's the match class, which has keyword attributes and keyword patterns. So this is a list of identifiers. Let's do an example. If you have a class pattern like this, you can say x equals I don't know the pattern, like x equals something and y equals something, right? So this is valid syntax. And the way this gets stored in the AST is a list of the identifier and a list of the patterns. Does that make sense?
Yeah, that does.
Right. And since you can create match class AST objects manually, we need to validate that these two things have the same size. And if they don't, we get this error. Well, I mean, we don't really have to validate it, because if you're creating AST objects, you're kind of on your own. But yeah, it's nice to validate that. There's also too many subpatterns, which is a limit we don't need to document. Can't use null keys in match mapping. This is another case that shouldn't happen in the parser. Constant mapping pattern checks duplicate key. Oh, so when this is when you do like say A needs to be X and A needs to be Y. Yeah, that's the error you get.
Oh.
Well, we're kind of straying away from the point of the formal grammar, I guess. But yeah, so this would be a mapping pattern. And that would okay. And mapping pattern keys may only match literals and attribute lookups. Oh. Okay, this is an interesting one. So the key must only be a literal or an attribute lookup. I guess this is also something you cannot get from the compiler. Right, if you put something like this here, you get invalid syntax. So you shouldn't get this from the compiler, but again, if you create the AST manually, then you'll get this error. Length mismatch again. Too many subpatterns. Alternative patterns by different names. Yeah, this is also something you cannot have. You cannot have like list as X or int as Y. So when you have these alternatives, they all need to bind to the same set of names. That would be for the or pattern. Next, multiple starred names in sequence. Go ahead.
What was the title of that error again? Multiple starred? No. Alternative patterns bind different names.
Right.
Was that it? Yeah. Okay, got it.
Oh, and
I'd just like to put those in the notes here.
Do I need to parenthesize this? Oh, yeah. That's the error. Multiple start names in sequence pattern. Okay. So we had some of these already. Where's the sequence patterns? You already have this one. patterns may only match literals and attribute lookups. We've already seen this one. Oh, this is mapping pattern keys, and this is values in general, but that should be covered by the grammar. Yeah, I'm pretty sure that's covered by the grammar. And there's invalid match pattern node in AST. Sure. And that's it. Okay, that's a lot.
Yeah, no kidding. Wow.
From codegen.c. And I don't know if there are any other syntax errors that come from later stages in the parsing. This compiler, I think I checked previously that's only called from codegen.c. There's a definition in a header file. But I wonder where else syntax errors can be raised. Apparently there's an AST validator.
Oh. Now, we haven't talked about the concrete syntax tree at all. That's something that... Is that...
Oh, the concrete syntax tree.
Yeah. Is that even related to the grammar, or is that like a different piece of the housekeeping?
Right. So we haven't talked about this because it's not something CPython actually uses. Or at least
I see. Okay. Okay.
Apparently, there's a C also. libcst parses code as a concrete syntax tree that looks like an AS tree and keeps all formatting details. Okay. So I guess this is a third-party project.
I see. Okay.
Maybe on PyPI. Yeah. Oh, it's kept up to date. That's nice. Okay. So this looks like an IST tree and keeps white space. Oh, and it says it's a compromise between an AST and a traditional CST. So I guess if you want to know what a syntax tree is in general, well, there's a Stack Overflow answer for it.
Of course.
Concrete syntax tree conforms to the context tree grammar, defining the source language. Okay. I see. Right. Okay. So if you want to know the difference between those two, let's look at some of the binary operations, like sum. Okay. So when parsing an expression, Python will try something plus something else and something minus something else, right? And if it parses that, it will create a binary operation AST node, right? Maybe can we use the AST module like this? No. Right. So the program a plus b is parsed as a binary operation where left is the name a, operation is add, and right is the name b, right? Does that
Yes.
make sense?
Okay. Yes.
Or when Python is looking for sum, it can just find the term, which means there's no adding or subtracting, but there is, for example, a star, right? Like this. So if I have b plus c, then Python needs to try the sum rule, and that doesn't succeed, but it does find this term. That makes sense? So
right.
in a CST, you would still have a node for this sum, and it would have the only child this multiplication, right? So that would keep a node in the tree for this sum, even though it only has one child. Does that make sense?
Right. It's almost like a table of, like an index rather than a table of contents.
It's more like not simplified, I would say.
Not simplified. Okay.
Right. The parse tree has nodes for all the rules here, even if the rule only has one child. In the CST, you get to simplify a bit, which is why we have these actions that say, what needs to happen when this rule matches. And anything that's not important just gets thrown away at this step. Right. So if we just have a term, we return the result of that term, and we don't need to keep the information that we went looking for a sum. So the CST, I guess, is more like a theoretical concept.
I see.
That you get when analyzing grammars, where you can be sure that if you have a shift expression, it will always have a sum node inside it.
Okay. Curious.
All right. In AST, you just get a binary operations, which can be basically anything. Or not just a binary operation. You can get any expression out of this, right? There's this await primary, which is primary, which can be an attribute reference or a call or a literal, a constant, and so on. Right.
So ultimately, CPython itself doesn't use the CST.
Yes.
It's just something that exists kind of as a resource for humans who might need to do something.
More like a theoretical concept.
Okay.
Right. When you take this grammar, you define a parser based on it. You can throw away all the C code in the rules.
Yeah.
You'll get back a CST. because
okay.
when you look at the grammar without the rules, which we have here, you have
I
no
see.
idea what's important,
Right, right. Oh, okay.
right? So you can't know that
Sure.
this inversion uh, and comparison. Like, do we need to keep the fact that this comparison was part of the inversion?
Right.
Right? That's not relevant, and Python knows that it's not
Right.
relevant at the time it parses it, so it discards the information.
Okay. Very good.
Also, we throw away all the tokens that aren't interesting, like these commas. Who cares? Or this if. Probably doesn't make it to the AST. Yeah, the token is just not present in the AST.
I see. Right. Okay.
Which also means you can't really reconstruct the source code from the AST. So
Oh, of
don't
course.
know how many
Okay.
spaces there were
Right.
between things.
Right.
Even though you might have tokens here.
Super cool.
Yeah. Oh wow, and I see we're out of time. Thanks for the discussion.
Yeah. No, thank you. Thank you. That was great.
That was interesting. And I guess I'll see you next week.
Yeah, man. Very good. Thank you.
We
Okay.
should resume normal programming.
Exactly. Okay. Cheers. Take care, man. All the best.